lecture is about extinction effects. In other words, what keeps an animal persisting in behavior when it's not reinforced? Well, that's extinction. So the animal's pressing a lever to get food, it gets food. What does it do when it doesn't get food anymore? Does it keep pressing the lever? And what might influence that behavior? Now, this has real good, real world application, especially with children. If you have a child that's showing good behavior, do you have to reward that behavior each and every time? And if you stop rewarding that behavior, what happens to the child? Do they keep doing that good behavior, or do they stop because they're just not getting rewarded anymore? That's what we're going to talk about here, and we're going to think about some of the results theoretically. So what we find is that the magnitude or the reward quality is inversely related to the rate of extinction. In other words, the more you give the animal, or the better quality of reward that you give an animal for doing a behavior, the more it's going to extinguish that behavior quickly. And we're going to learn a little bit how. That seems a little odd. The better reward, the faster the extinction. So it's doing this behavior, it's getting this fantastic reward. As soon as you stop rewarding it, it stops the behavior rather quickly. The greater the magnitude in training, the quicker their extinction. And this seems a little paradoxical, especially when we talk about Thorndike's theoretical law of effect, which is simply stimulus-response associations are created when what follows is rewarding. The better the reward, the stronger the association between S1 and R1, and the greater likelihood that animal is going to persist in that behavior. But just the exact opposite happens with extinction. The better the reward, the faster they're going to stop when they're not rewarded. So you might have a training and you might look at response speed. And here's the animal right here in black. They get great rewards, really high magnitude rewards. They're loving it. But as soon as you stop, their behavior is going to drop off very quickly. Another animal got kind of a mediocre reward in quality or quantity. And during extinction, it still persists its behavior longer than the other animal. One of the most famous studies on this was done way back in 1971. It was a really big study. Ratliff and Ratliff trained 224 rats. That's kind of unheard of today, to run that many animals. But they divided them up into different groups. So one group received 2 pellets of food for running down a runway. Another 4, another 8, another 16. And in this case, there was an additional component to the research. So now you have broadly 4 groups getting different amount of food, but then you've subdivided those 4 groups into additional 4 groups. And that depended on how often they got rewarded for running down the runway. So here we go. We have a group of that got 2 pellets of food. Some of them got food only 1 out of every 4 times they ran down the runway, 25%. Some got it every time, 100%. Some got it half the time. So each of the 4 magnitude of reward was subdivided into whether they got rewarded partially or continuously, as in 100%. So here's what they found in acquisition. This is not surprising. The magnitude of reward increased the speed at which they learned, learning rates. You get 16 niblets of food and you're a hungry animal, you're going to learn really quickly compared to animals that only got 2. Also, if you got rewarded every single time, 100%, you're going to learn faster than if you only got rewarded 1 out of 4 trials. But this is the interesting thing. What happens when these groups stopped? So each group is subdivided into 4. So that was 14 animals in each of these subgroups. That's, again, a big experiment. But what this graph shows, this comes directly from their experiment, is that an animal that got 16 niblets of food, huge, and got rewarded every time, extinguished very quickly. This is a measure of resistance to extinction. It's supposed to be a 0 there. The higher this number, the higher this value as they rated it, the more likely the animal was going to be persisting the behavior in extinction. We call that resistance to extinction. In other words, the longer the animal just kept running down the runway over and over. Well, if you got rewarded every time 16 pellets and suddenly you get nothing, you show very little resistance to extinction. In other words, after only a few trials, they plop them in. That animal's just sitting on its butt, not doing anything. The lower the reward, the greater the resistance to extinction, and the greater the partial reinforcement. Only 1 in 4 times did they get food in this group and in this group. And yet they had really strong resistance to extinction. They kept going. Here's an animal that only got 2 pellets of food during training and only got those 2 pellets 1 out of every 4 times it ran down. It has one of the highest resistance to extinction. Again, this seems a little paradoxical. And we're going to try to unfold this and see why. So now we get into what's called the partial reinforcement extinction effect, PREE. Continuous reinforcement, we know what that is, a reward for each behavior. That's continuous. We've talked about that before. And then we have partial reinforcement. That means not every single action, target response, running down a runway, pressing a lever, pecking key, not each time are the animals rewarded. They're put on a schedule, a fixed ratio, a variable ratio, a fixed interval, a variable interval. And we already have learned that this variable interval really keeps an animal having a high rate of behavior. Following training, animals receive extinction. Extinction is simple. They do the behavior, they get nothing. They get no reward. Results are that the partially reinforced animals are more resistant to extinction. In other words, they persist longer. Even though they're not rewarded, animals that got rewarded each and every time, they stop their behavior quickly if they're not rewarded in extinction. And another animal who gets rewarded only sometimes for their behavior, they really persist. They keep the behavior going. This is sometimes referred to as Humphrey's paradox. It's just kind of another name for the partial reinforcement extinction effect. Behavior that is rewarded more often may extinguish quicker than partially reinforced behavior. Again, it seems a little paradoxical in that the first animal got more rewards. A continuously reinforced animal is rewarded more often, should have a stronger SR association. Another animal doesn't get rewarded as often, so shouldn't have as strong of an SR association and should be a little bit weaker in its ability to persist, but just the opposite happens. So let's take some examples. A continuously reinforced animal would be on what's called a fixed ratio of 1. Simply fixed ratio, meaning all they have to do is one behavior to get reward, FR1. And a partially reinforced animal, well, it just depends on what we want to put them on, but let's say we put them on a variable ratio of 4. So here's a continuously reinforced animal. You plop them down, they run down the runway, blop, they get their food. Every single time they do it, they get food. Every time they're put at the beginning, they run down and get food. The partially reinforced animal is plop down, runs down, gets some food. But maybe the next trial runs down and it gets nothing. It's done the behavior. And if it's on a variable ratio 4, it has to, on average, run down 4 times in order to get reinforcement. 3 out of the 4 times it runs down, it gets nothing. Partially reinforced. Then we put both animals on an extinction. Extinction is simple. Run down, get nothing. And we clock them. How long does it take them to get down? The latency, and we look at speed. And so initially, first trial of extinction, they're both running down pretty quickly. Everything's fine. And then they get nothing, and then they put them in again, and already we start seeing the continuously reinforced animal slow down. That partially reinforced animal, it's still going. This animal down here, the one in the orange, it got rewarded more times, a lot more times than this animal. And yet this animal extinction just keeps going down. The continuously reinforced animal after a while just stops. But that partially reinforced animal persists. Again, this can be really important when dealing with child behavior. Right? So if you're working with a child, and let's say you're working with a child in applied behavior analysis, or a child, working with a child with learning problems or behavioral problems, and you want them to do good behavior. So when they do good behavior, you give them a little token of a reward, right? Sometimes in classrooms we call this a token economy, meaning, hey, here's a sticker, and here's a little sucker, and here's a way to go. And then you say, well, I really want this behavior that I got them to do, concentrating for 5 minutes, doing whatever. I want them to do it all their life. I want them to do this at home. I want them to do it all the time. The thing about it is, we aren't rewarded all the time in our life. So if you really want to have this child persist this good behavior, do not reward them every time. You might start with a more continuous reinforcement, but after a while, they have to do the behavior and get nothing occasionally. And they maybe give them a little reward now and then. And that behavior that you're trying so hard to continue in that child will persist when they're outside the classroom, when they're at home, when they're not getting these reinforcement schedules. So here's what it might look like. I've just kind of made up some data here. Latency to run in seconds. The continuously reinforced animal might actually run a little faster during acquisition than the partially reinforced animal. Depends on what you're doing. Sometimes they reach the same asymptote. Radcliffe and Radcliffe found the same asymptote. But as soon as we start extinction, the continuously reinforced animal slows down really quickly, but the partially reinforced animal persists longer in their behavior, even though they're not rewarded. So how do we deal with this paradox? Well, first, I want to talk methodologically. There's a couple ways of doing this, and we might need different theories to account for behavior under different methodological conditions. So I want to differentiate between 2 types of trials. We call them massed trials and spaced trials. So in a mass trial, there's a very short ITI. What does ITI stand for? Inter-trial interval. And you're going to use small rewards because you don't want to get the animal all full. So if we're talking about an animal running down a runway, like we were showing, the animal is placed in the start box, runs all the way down, gets some food or not, and then we plop them back at the start again, really quickly. The next trial starts really quickly. Runs down, gets some food, and there might be only a few seconds before we start another trial. That's a mass trial because all the trials are massed together. One after another after another. And if the animal ran down the first one and we gave him this giant thing of food and then we started him again, animal's full, it's not motivated, right? Doesn't find the food rewarding. So you have to use tiny niblets of food in mass trials. Space trials, simply we have a long ITI. The animal runs down, gets some food, and then he goes back to his cage for an hour or 15 minutes or some length of time. It's not just 30 seconds or a minute. It's usually over 15 minutes. It might even be 24 hours. And in this case, we really don't need to worry too much of whether we use small or large rewards, because the animal runs down, gets a large reward, and it's back in its cage for 2 hours. It's going to get hungry again. Okay? And we're going to get the partial reinforcement extinction effect in both cases, but for kind of different reasons. So let's deal with theories of massed trials. So hopefully by now you're understanding the methodology of mass trials. Just one trial after another with a very, very short break. The theories are really based on what's called discrimination of training. We call this the discrimination hypothesis. When I say discrimination, I'm saying the experience they have in training is discriminated from or different from the experiences they have in extinction. And because of that discrimination, the animals, this is a different thing, and their behavior goes down. Training and extinction, the stimuli that they're experiencing are more similar in the group that's partially reinforced. So, one theory in mass trials that deal with this discrimination hypothesis is known as the sequential theory, or sometimes the sequential after effects theory. And this was proposed by Sheffield and Capaldi. And the idea is, again, we're going to be really reductionistic here. We're going to be using very parsimonious language when talking about this theory. Occasionally we might divert into talking like they're little humans, anthropomorphism, but I really want to focus on the parsimonious interpretation. Okay, so stimuli are carried over from the end of one trial to the beginning of the next and become part of the initiating stimulus. In training, the S1 is different from the S2 in extinction. That's in the continuously reinforced animal. The partial reinforced group, training and testing, are similar in terms of the S1 that initiates the behavior. So here's the idea. This is again Capaldi and Sheffield. Let's picture an animal in a runway and it runs down. S1, that's the start of the runway. R1, that's running down to the end. S2, that's a little niblet of food. And because this is a mass trial, we're going to do another one right after. Start box, run down, get some food. Start box, run down, get some food. This is a continuously reinforced animal, so you can see each and every behavior is rewarded over and over and over again. And the idea is that stimuli from a previous trial is carried over and is part of the initiating stimulus in the next trial. And, well, it depends on who you're reading, right? So Sheffield might say things like, there are sensory after effects. Like, for example, the animal eats some food and starts right away. Well, what stimuli is the animal experiencing? The start box, good, the S1. But it's also got a little food in its mouth. That's a pretty strong stimulus. Do you know when you have food in your mouth? Yes, you do. That's a stimulus. When I'm at the start box and I have food in the mouth and I run down, I get rewarded. Capaldi talked a little bit about patterns. Like, I have just received a lot of reinforced trials. That's all part of what I'm dealing with. So here I am at the start. What do I got? I got lots of memories of reinforced trials. I have seen the pattern of reinforcement after reinforcement. This is how I was trained. Animal runs down, gets itself some food, the continuously reinforced animal. It is then placed in the start box, and now it's running down again. It was really fast, and it's chomping on some food from the last trial. These are salient stimuli carried over from previous trials. What specifically do I mean that's carried over according to Sheffield? Carried over the food in its mouth. Capaldi talked about memory. I remember. I just got rewarded. I just got rewarded. I just got rewarded. Or patterns. I got the sequence of rewards. So if we're talking about Thorndike's theoretical law of effect in its purest form, what stimulus causes behavior in a continuously reinforced animal? What stimuli creates an association with the target response, in this case running from one end to the other of a box, that is then rewarded to strengthen this association? Thorndike's theoretical law of effect. Well, there's the start box. Good. Okay. Yeah, I'm always at the start box. I'm in the start box. I run down, and there's some food, and that creates that association. But there's lots of sensory carryover. I got food. I'm still chomping on the food from the last trial. I'm still picking it out of my teeth. I'm still salivating. I'm still doing all these things. Those are very powerful stimuli, and they need to be there because those connect to the response. And this is more Capaldi. I have memories. I have short-term memories of being reinforced over and over and over again. When I experience the start box, the sensory carryover, chomp, 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 food in the mouth, and memories of reinforced trials, when I'm experiencing all those, that creates a connection to the R1. What's the partially reinforced animal experiencing? Remember, it runs down, it gets food, it starts right away, it runs down, it gets nothing. 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 It runs down, it gets some food. And then it runs down and gets nothing. What's the stimulus that initiates the behavior in a very Thorndikian manner? The start box. Sure, when I'm at the beginning of the start box, that is a stimulus that is connected to the behavior. But also, there's not a lot of sensory carryover. Because if it just ran down 5 times without being reinforced, it's eaten the food. It's gone. It's not there anymore. And there's a lot of memory. There's memories of, there's a lot of non-reinforced trials. But occasionally, a partially reinforced animal is going to be in the start box. It's not going to have any food in its mouth. And it's going to have short-term memories of a lot of reinforced trials, but then it gets rewarded. It's partially reinforced. This stimulus, or series or collection of stimuli, is connected to the R1 because occasionally the S2 comes. They get their food and they're hungry and it's rewarding. The continuously reinforced animal extinguishes more quickly because of a discrimination between the S1 in training and X1 extinction. What is extinction? What is the animal experiencing in extinction? I'm at the start box. I run down, I get nothing. I don't have any food in my mouth. I start again, I get nothing. I start again, I get nothing. I start again, I get nothing. Trial after trial after trial of getting nothing. And this animal who's continuously reinforced, the only stimuli that are really there for them is the start box. Does it have any food in its mouth? No, because trial after trial, it's got no food. So what? It's not chomping on anything. There's no stimuli of food in the mouth. Is there memories, short-term memories of reinforced trials? No. In fact, I got a lot of memories of non-reinforcement. That's not how I was trained. That is not connected to my target response. What about the partially reinforced animal? Oh yeah, I got the start box. But there's no sensory food in my mouth, no carryover. Yeah, that's an extinction. That's how I was trained. Do I have memories of a lot of non-reinforced trials? Yes. That's how I was trained, because occasionally I get rewarded. When I'm at the start box and I have no food in my mouth and I have memories of non-reinforcement, I run down, I get some food. That happened a lot in training. That's really similar to extinction. This is just like I was trained. I'm going to keep persisting. It's just a discrimination thing. The continuously reinforced animal was not trained like this. The stimuli that initiate behavior are not there in extinction, but in the partially reinforced group, they're there. And so they push that behavior forward. Another piece of evidence that seems to support this idea of sensory carryover, that stimuli at the beginning of a trial are not just the start box, they are other things, is an experiment called single alternation experiment. Single alternation. Animals trained on an FR2. Run down, get food, run down, get nothing. Run down, get food, run down, get nothing. Run down, get food, run down, get nothing. And it's a very specific pattern. There's no variability here. Every other reinforced trial is rewarded. If the animal discriminates S1 for rewarded and non-rewarded trials, the pattern behavior should look a little like this. So in blue is the rewarded trials. So on the very first trial, it runs down and gets some food. And it's a happy-go-lucky animal. It's all excited, and it runs really fast down, and it gets nothing. Now it's a little discouraged, and it runs slow on the next trial. And what we find at the beginning of training is it runs slow on rewarded trials and fast on non-rewarded, because it's just like, oh, I just got rewarded, I'm going to run down. Oh, I didn't get rewarded, I'm going to slow. Oh, I just got rewarded, I'm going to run fast. Oh, I didn't get rewarded, I'm going to run slow. But that pattern changes. After a little bit of training, we start seeing sort of evening out, and then it reverses. On a rewarded trials, it runs quickly. On non-rewarded trials, it runs slowly. Why? Because if we're starting a rewarded trial, we don't have as much sensory carryover because you just got nothing. Not as much sensory carryover in the mouth. A memory of a previously non-reinforced trial, that it has a strong connection to running because it gets rewarded. Now we're on a trial where the animal doesn't get anything. It has food in its mouth. It has a memory of reinforcement. And that is not, those stimuli are not connected to running quickly, because those, when the animal has food in its mouth and it has a memory that it just got rewarded, on that trial, it's not going to get anything. So it slows down. And now we're going to go and start the next trial. It has little food in its mouth because it just didn't get anything. It has a memory of non-reinforcement. That is connected to running quickly, because whenever they experience that stimuli and they run quickly, they get food. And so we get this pattern of running slowly, taking many seconds on non-rewarded, and running quickly on rewarded, all because of a discrimination between the two types of stimuli, the rewarded trial beginnings and the non-rewarded trial beginnings. Okay. Now, some of the strong evidence for Sheffield was work that she followed up with. She said, oh, it's sensory after effects. If I get rid of the sensory after effects, I should get rid of the partial reinforcement extinction effect. That's her theory. So instead of the animal having food in its mouth, I'm going to do a trial. I'm going to wait 25 minutes. Oh, it's chewed on its food. It's eaten its food. That stimuli are gone. Those stimuli are gone. The short-term memory of previously reinforced trials, those are gone. Short-term memory doesn't last 25 minutes. And sure enough, when she ran this experiment, she used the same amount of rewards, tiny little rewards. They lost the partial reinforcement extinction effect. The partially reinforced animal did not persist longer in extinction than the continuously reinforced animal. Okay, evidence. Good supporting evidence. And everybody was loving it until Weinstock came along. And Weinstock ran an experiment where he had an intertrial interval of 24 hours. The animal ran down, got some food, and then sat in his cage till the next morning. 9 a.m., the animal ran down, got some food, and then was put away for 24 hours. two groups of animals. This took a while to run. One group was partially reinforced, and another group was continuously reinforced. So how do we explain it? At the time, people started questioning Sheffield. They said that she made up her data, that she wanted to support her hypothesis. The truth of the matter is we need separate theories to account for this behavior. One to account for mass trials and one for space trials. Here's the difference between Sheffield and Weinstock. Sheffield used tiny little niblets of food. Weinstock wasn't worried about that. Weinstock said, 9 in the morning, just have them run down, give them a big globule of delicious food. Doesn't matter because they're going to be hungry the next day. We don't have to worry about the animal getting satiated. So if the reward is small, the partial reinforcement extinction effect is lost in space trials. There's no sensory carryover because it's just too long for the animal to keep food in its mouth. There's no short-term memory of rewarded and non-rewarded trials because, again, the animal's not keeping those things in short-term memory. Mass trials, it makes sense. The animal runs down, gets some food, put them right back in, ready to go again. If rewards are large, the partial reinforcement extinction effect appears again. There's no sensory carryover, but we have something else going on. Now we get into a theory of the partial reinforcement extinction effect in space trials, lots of time between each trial, with large rewards. This theory is called the reinstatement of frustration theory. Large rewards are associated with the training apparatus. It's where they get the really delicious food. Continuously reinforced animals group are never frustrated in training. Why? Because every morning at 9 a.m. they run down to the end and they get a giant globule of food and it's delicious and everybody's happy. Every single day they're happy to be in that environment because that environment's associated with big giant things of food, and they run down and they get their big thing of food, and that's great. The partially reinforced animal, however, a lot of times at 9 a.m., they're hungry animals. They're put into that box. They're taken out of their cage. They're put into that runway. They run down and they get nothing. But they associated that environment with delicious food because sometimes they do get that delicious food. They're partially reinforced. So they have expectations. So now we're getting back to Amsel's theory of frustration. The animal has expectations. I'm going to get a big giant globule of food. I didn't get it. Gosh darn it. I am frustrated. I am frustrated. And this environment that they're in is associated with two things. Big globule things of delicious food and the emotional state of frustration. And sometimes the partially reinforced group is put into the beginning of that runway. 9 in the morning. Hasn't been there since the day before. And it's like, I know this place. This is one frustrating place. And they meander on down and they get rewarded. They're partially reinforced. They're going to get rewarded sometimes. And the animal was just rewarded for persisting, for running while frustrated. In the face of frustration. Persisting in the face of frustration. So let's use my horrible animation to demonstrate this. Little rat, partially reinforced animal comes down. Chomp, chomp, chomp. Ooh, this is giant thing of food is so very delicious. I associate this area, this runway, with delicious food. I'm back in my cage. I'm hanging out. 24 hours go by. I'm not thinking about that box anymore. I'm not thinking about anything. I'm just hanging out in my cage. I'm put back. I love this place. I associate it with this delicious cheesy food. But it's partially reinforced. It runs down and gets nothing. And remember, we're not going to do this twice. We're not going to do this 3 times. This animal is trained for months. Sometimes it gets rewarded. Sometimes it doesn't. And the days it doesn't get rewarded, that animal's pissed. It's hungry. And it gets down there and it has expectations for some delicious cheese. And it's not there. Frustration. As we've learned, frustration is conditionable. So this area, because of Ivan Pavlov, this area is associated with frustration. And he goes back into his little cage. I'm feeling pretty good here. I'm not frustrated here. I'm feeling fine. I'm going to hang out in my cage and do nothing. And the next morning at 9 a.m., he's put back into this cage, back into the runway. And he's like, I'm here again. Oh, this place is associated, classical conditioning, with an emotional state of frustration. This is a frustrating place. I've been here day after day after day. And I want food because I'm hungry and the food is so good, and lots of times I don't get it. And he walks down there and, hey, wait. I was rewarded for running while frustrated. I just got cheese. It's partially reinforced. Some days it's going to get cheese. The partially reinforced group was rewarded for persisting while frustrated. Do you think extinction is frustrating for these animals, even if we do it every day at 9 a.m.? Do you think this is frustrating? The continuously reinforced animal has been rewarded every morning at 9 a.m. for the past 3 months. Now in extinction, it's plopped down in there, it runs down, it gets nothing. Do you think that's frustrating? Yes. It's very frustrating. And the next day, it gets nothing. And now it's super frustrated. And now this area is associated with frustration. But the continuously reinforced group was never rewarded for persisting while frustrated. The partially reinforced group comes to the thing, runs down, gets nothing. Yeah, okay, I'm frustrated. But the training I received the past 3 months, sometimes I'm rewarded for persisting in the face of frustration. Extinction is frustrating, but I've been rewarded for persisting while frustrated. Sometimes I get reward. They were frustrated during extinction, so they persist. This is a really valuable lesson that we apply to a lot of aspects of child development. The idea is that in a broader scale, sometimes children are given awards for just participating. Sometimes that's kind of nice. But sometimes it might be a little healthier for loss to be part of it, for frustration to be part of it, to play a game and to lose and to be frustrated by it, or study for an exam and not do well and be frustrated by it. But occasionally you keep persisting. They keep trying. They keep working hard. They keep studying. They keep practicing. Sometimes they're going to win. That's such a valuable lesson, that they persist in the face of frustration. Let me tell you something. As you know, life is frustrating. When they become adults, the adults lose all the time. We try hard all the time. Things fail all the time. I see this in my research. I have a great idea. I conduct some research, and we don't get supporting data for my hypothesis. But sometimes we do. And if somebody gets rewarded every time with these, oh, you did great, even though you lost, even though you didn't try hard or whatever, you're still a winner. Everybody's a winner. Everybody's a winner. When they get into adulthood, nobody's giving them trophies, and they haven't really been rewarded for persisting while frustrated. That's an important lesson. And it carries from animal training to children training to adult training about the importance of loss and the importance of failure and the importance of teaching children that persisting through failure is so very important, because that's what you kind of have to do the rest of your life. All right.